Okay, welcome. I can see there are a few people out there, so thanks as always for being here. Sorry, I got a bit of a headache because I've been reading code and playing games for several hours today. So if I seem a little distracted, it's because I'm tired. Hey, Kevin K, nice to see you. So anyway, they're all done. Uh, all of the projects are done, and you'll find in the feedback in the comments section on your submission, I attached files with the scoring rubric filled out for each one of you. So that's where all the details can be found. I'm going to do demos at the end just so that I don't feel rushed to get through them, because some of them, um, there's some really cool stuff that some of your classmates did. So anyway, I'm putting demos at the end. And because this is the week of Thanksgiving, um, I'm going to try to be fairly efficient and move us along through the content um, without too much messing around otherwise, which probably means that I'm going to end up solving much or all of the lab here on the live stream. So that the live stream will be shorter. You watch it, you can walk away having seen the solution that you can implement. So that's my plan. Pick one of the sections to go in. I should have taken something. I've got a good headache going. So I know that just after, for many of you, this was a last second and beyond scramble. I feel very powerful sometimes after I have a project due, because I create so much chaos in Butte County. So I caused internet outages and all kinds of illnesses and several other problems. And I'm not saying those things aren't the case. It's just, it's weird how that works. So sorry if you had a rough time of it. Hopefully for the next project, you can sort of think ahead and try not to leave yourself sitting there on Sunday night scrambling to try to finish. So there is one more project. The time to start it is now, or shortly after you give yourself some breathing room around the Thanksgiving holiday if you do that. But anyway, it's due on December 11th. That's the Sunday before the last week of class. The last week of class for us, we won't have an exam because I don't do exams, but we will do a little C++ boot camp. So we'll take actually what you're learning for the next 3 weeks, and we will implement that same code in C++ as a way to sort of help those of you who are moving on to programming and algorithms 2 next semester or in the near future. You'll have a little bit of C++ exposure, and my hope is that you won't find it that intimidating, because it's not. I think Go is a much cleaner and more elegant language than C++, but they're very, very similar. Okay, so next project due on December 11th. So start the time to read what that project is sooner than later. And the time to get to work on it is as soon as you can get the energy up to do so. Okay, we're in week 14, 4 weeks left, 14, 15, 16, 17. Yep, 4 weeks left. So we are adding a new thing. I think this is our last new thing. There are other new things in Go, but they are beyond the scope of our class. The last new thing is called a struct. This is arguably the feature of the Go language that makes the Go language what we call object-oriented. So you're going to hear me use some new terminology starting this week. I will talk about objects and instances, and it takes a little bit of time to get accustomed to that terminology. These are abstractions, and by that I mean they are ideas that we represent in Go programming code that are meant to represent something sort of in the real world, if you will. So anyway, abstract things are difficult to work out in one's head. So be patient about it. There's a little bit of new terminology. There's some new syntax. But with this is our last new thing, and we are pretty close to being tooled up for what we need for the fourth project after this struct concept. Okay, so there's a few readings about that. Homework is always on those readings. Let me de-zoom this a little bit. We have a lab, which let me pop it open from here, and then I can come back to those tabs later. The lab this week has a unit testing component, and it also has an application component. So be on the lookout. In fact, let me just go back and call your attention to it now. If you look at the requirements for this week's lab, of course, documentation, good formatting, and then 60 points for numbered comments. That's the application component, and then 30 points for the unit test. So it's got both components. I think you've done this before in the last few weeks, where you have to do some things in main, and also there's an associated unit test. Discussion this week is asking you to go do a little bit of research about object-oriented programming. And this is sort of giving us extra terminology. This is also kind of the things that you want to have in your experience if you move forward in programming. So anyway, we'll start the research and the discussion on it, and then I'll be talking about it a little bit today and a little bit in the next couple of weeks as well. And then reminders, so homework lab discussion as always, because Butte College basically considers itself to be doing its instruction for pretty much the full week. We're not going to take a break, although I am going to give you probably all of the solution for your viewing pleasure and for your use if you want it, just to make your life a little bit easier around the Thanksgiving holiday. But otherwise, we're having a normal week in terms of work. And then Project 4. I know we just finished a project, and it is irritating that there's no break, no room to breathe between Project 3 and Project 4. But in my opinion, it's the best way to learn programming is to do projects. The labs are helpful to expose you to the concepts, kind of isolated by themselves, but the projects are really where you take all of the various concepts and put them all together at once to make an application. So please go read that, although I'm not going to do that today. I'm going to do the project stuff. I'll read through it when we come back next Tuesday. Okay, so structs. Let me make myself a REPL for this. My headache's not going so good. Okay, so I'll sort of, and I'm going to try to be efficient about this so that we're not sitting here for an hour and a half or 2 hours, sort of going into a different kind of week. Anyway, so a struct. A struct is simply a way to collect together multiple variables in one place. And the idea is, so let's say, for example, I wanted to represent, I don't know, what do I want to represent? We'll say a car. So if I were to represent a car in software, the way I would, and the term we use, by the way, is model. So we will say that we model something in software. And what we mean by modeling something as programmers is that we identify the useful or important or interesting characteristics of something in the real world. And then we try to translate those characteristics of a real world item into what we can represent in software. So a car is an example. There's kind of some obvious ones. So we have a make, we have a model, we have, oops, that's a string. We have a year. We might have gas mileage, miles per gallon. We might have a price. Maybe it'll have a color. So anyway, this is kind of how we might model a car in software, is a series of variables, kind of each variable being one characteristic of the car. I think most people kind of understand that out of the box. So that's all fine and good, but what if we need two cars in our software? what if we need a second car? Well, if we need a second car, what we usually end up doing is we do something like, well, I'll number all of these. And then I will grab a second set of those. And I will number those for car number 2. So one of the problems of modeling like this, where we just sort of have the variables, is that to scale the model, and by scaling the model I mean to represent more than one of those things. So if I want to represent more than one car in my software, I have to scale up the number of variables to match the number of cars. And of course, if I want a car 3, then I got to go through the whole process. And before you know it, just for 3 cars, I've already got almost 30 lines of code. So the problem with this way of modeling something in the real world is that it does not scale up well. To get more cars, I have to have a lot more lines of code, and it just keeps growing and growing and growing and growing. So one of the solutions that we have, that we could use to model multiple cars, would be to use arrays or slices. So I could, for example, create a series of slices to represent multiple cars, the makes of multiple cars, the makes of multiple models, the colors, make, model, color, year, the years, the MPGs, 64. And the prices. By the way, notice my scaling problem here is that I have copied and pasted myself into a mistake. So you may or may not remember, but we did. So this is parallel arrays, slices in this case. So this is one way that we have that we can scale up data a little bit better. And really, if I wanted to, I could turn these into arrays and say, well, I want 10 cars worth. Put that one in the wrong place. So now I have used arrays to scale up the data that I can use to represent those characteristics for 10 cars. And then, so the idea would be that makes at slot 0 would be the make of a car, and model at slot 0 would be the model for that same make. Color, year at 0, mile per gallon at 0, price at 0. Those would all be for that one car in parallel. So that's 2 ways that we can model something from the real world. And you'll notice that the parallel arrays one does scale up better. In fact, it scales up a lot better because I can very easily alter this to be 100 cars worth of data if I want to. So that's all fine and good. We do have a way to scale up data by using arrays, but we still have a problem. At least what I hope you'll come to believe very quickly is that this is still not ideal, because we don't have the data sort of all bundled up together for one car. We have to go to the makes array at a slot, and then we have to go to the models array at the same slot, and then we have to go to the colors array at the same slot. So we don't have one entity that represents the entire set of data that we would like to associate with a car. So this is better than the separate variables approach, but it's still kind of a mess, especially when we're trying to think of it conceptually. Like, what is a car in my software? Well, it's a bunch of arrays with a bunch of crud in it. So what we are introducing this week is a way to create sort of a bundle called a struct, where we can define sort of a blueprint for a thing that we want to model in software. So the way you do that is you declare a new type. That's a Go language keyword. You name the type, whatever you want it to be. This tends to be what you want it to represent. So I'm about to represent a car or model a car in software, and then the keyword struct, which is the Go technique that I'm about to use. So I'm actually creating a data type called a car, and it is a struct data type. So by data type, I mean I will be able to declare variables of the type car. By struct, it means that I can actually gather together all of the pieces of data that I'd like to associate with a car. And it's hard to see. Oh, I can't use make, can I? It's blue, so that's not gonna work. Maker, I'll call it. So we get around that blue, which means I can't use it. Okay, so this is now how I'm going to model a car. I'm going to create a custom type called car with a capital C, which is a struct. And what a struct allows me to do is bundle together multiple variables. In fact, I can bundle together all kinds of goodies inside of here. I can put slices in here, arrays in here. I can put other structs if I want to sort of assemble with various parts something. We're not going to worry about that just yet. So here's how I want to model a car. And that's all this is my statement in code of how I would like to represent cars. All right, now let's go move these guys out of the way. So those are they don't scale very well. So now let's see how we would use our new type. So what does this allow us to do? This allows us to do this. Sorry, wrong language. This allows us to actually create variables of our newly defined custom data type. Yeah, so Kevin K is noticing that this would have been useful in project 3, and I'm glad you're having that. I half apologize and I half appreciate that you saw that, Kevin K, because that's what we kind of always hope that people will do when we introduce a new technique is think, wow, if I'd have had that technique, I could make use of it. So that's great because you already kind of can see how you might have used this technique to make your life easier on an earlier project. And this will be the technique that we use to try to make life easier on the last project. So it's a very good insight. Okay, so what's the idea here? Well, when we're actually using this custom data type, it scales quite well. Because we can just create a bunch of R's that are cars. And that's quite nice. So there's 3 cars. We're not going to do it this week, but you can actually do this. You can make slices and arrays of cars. Conceptually, what's difficult about this is to understand that C1 is all of these things in one place. So part of the trick will be, well, how do we access all of these pieces of the car that's C1? And we'll look at that in just a second. So let's get some terminology out of the way. C1 is a instance of car. This term, instance. So we use the term instance in object-oriented programming to say that we have taken our custom type and actually created one of them. We have instantiated it is the fancy term for that. So if I were reading this code on line 17, I would say C1 is a car, meaning it is an actual instance of one of these kinds of things. It's just like every person is an instance of a person. We're all unique, but we also have many of our sort of characteristics can be described as being common characteristics. C2 is an instance of a car, by the way. It's not a instance, it's an instance. C3 is an instance of car. So that's the term, and what we mean when we say instance, and what I hope you get to thinking when you hear instance is it's not just the type being described, it's actually one of those things. This is how it works in every factory in the world, of course. There's a plan or a blueprint or instructions that describe a car or a chair or a computer or a donut or whatever. And then someone actually takes those instructions, which for us is this type car struct, that's the instructions. They take the instructions and they create instances, right? So when I make a donut, that's an instance of a donut. And we much prefer, at least I do, to have many instances of donuts if I have any donuts. All right, so anyway, those are just ways to help your brain think about this. So C1 is a car. In software, at least, it's an actual car that has actual data that we can manipulate in our code, which is what we're going to do next. So let me comment out C2 and C3, and let's just experiment on C1. So what can you do? Well, one thing to note is when you create a car this way, all of its fields are going to be in their 0 states. So I'm going to quickly, I hope, it's already 4:20. Spin up some outputs. So how do we access the fields? The way we access the fields is we take the instance that we want to work with, in this case C1, we use a dot, and then we describe, or we list which field we want. So I want the maker here. So C1.maker is the maker field. So we call this dot notation. It's not a period, it's a dot, unless it's sitting at the end of a sentence, and that makes it a period. Otherwise, it's just a dot. So the instance, followed by a dot, followed by the field we are interested in. The field maker is a string. So when I print that field of car C1, I'm going to verb string. And I'm going to quickly spin up all the others. There are 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Car C1 make, car C1 model. Use the dot on this side to get the model. Color. Use the dot on this side to get the color. Year. MPG. The year is an int. The miles per gallon is a float. I'll do it to 1 decimal place, and then the price, which I should probably put a $sign in front of that, and then I will do that to 2 decimal places. Price. So that's an example of using the dot notation on an instance of a struct. C1 is an instance of the car struct. So I take an instance, have to have an instance to use the data. I use the dot notation, and then I specify which field I am trying to access. Now, if I run this, these are all going to be in their 0 state because I have never actually associated any data with any of them. So the 0 state of the make, which is a string, is nothing. The 0 state of model, which is string, is nothing. 0 state of the color is a string, is nothing. And then the integer is an actual 0, and the floats are actual zeros. All right, so how do we populate the data? Same way. We take the instance, we use the dot notation, and then we access the field, and then we do what we want to do with the field, which in this case, I don't know, I'm feeling sporty, I guess. I think it's got to be red. The year, I think they were cool like back in the 60s. And oh, MPG. This part was probably not cool back in the 60s. It was probably like something terrible, like 8.5 or something. And then whatever the current price would be, which would probably be a lot. 65,099 cents. Okay, so there I'm using the instance of a car, because that's the only way for there to be actual data, 3 miles per gallon. Can I put 3.5, Kevin? Okay, I'm going to do that just so it looks interesting on the screen. Or 3.2. Okay, so I'm using the dot notation, but now I'm using it to assign data to the fields in C1. So the cool thing is that C1 kind of carries around all these fields, and then when I need the individual pieces of information, I use the dot notation to get them. Let's take this same printout and make sure that the changes applied. All right, so there's the update. It's red Ford Mustang 65, 3.2 miles per gallon, $65,000, which is probably way less than they actually would be anymore. Okay. So there's my car, C1. I'm going to comment that one out. Okay, so there's some other things we can do. We have different ways. You're probably not surprised that because a car is effectively a new kind of fancy variable, it's a type, we have different ways of initializing them. So if we just declare a car var, then we get an all zeros instance. We can also do, I'll do C2 this time. We will end up using this, but there's a new operation, new car. This will create a car with all zero stuff in it. I'm going to see if I can, let's make something a little bit better. So let's see, it'll be let's put the year, a 1965, color, make, model, comma, the price, and then maybe in parentheses I'll put the miles per gallon. So we're going to do a whole bunch of car stuff, and in fact so much of it that I'm probably just going to start on the next line down. So the first field is going to be the year, the second field is going to be the color, third field is going to be the make. I had to put an R on it to get around the Go language. The third one is going to be the model. Then we have the price. And finally we have, let's drop these last two down. It's getting a little long. Where does it want it to go? I guess it does want it spaced over. All right, I can accept that. MPG. This is another one of those don't have super long lines in code things. So let's just look at this new car, which is going to be all empties. So this way of creating a car, a struct instance. So C2 is an instance. Created using the new function in the Go language. So that's what C2 is. And notice that it is all zeros. So let's look at some more C2s. So we can also do this. We can say C2 equals a car, and then with curly braces, which kind of match the struct, we can load up. So, oh, I don't know. Oh yeah, I think we've done a Prius in here. So you can also preload at the moment that you create a car instance. You can actually preload all the fields if you do them in the right order. So I go make first, followed by model, followed by color. See a lot of white ones out there for some reason. Followed by a year, let's say 2022. Are they still making them? I don't know. Followed by miles per gallon, which is a lot. And followed by the price, which is also a lot. I don't know how much they are. I don't have one. 21.97. I don't know. It's a weird price. Anyway, so we can also create instances of structs where we preload all the fields. And I'm just going to prove that by running it, and it will have all the data kind of loaded up in there. So that's a different way of creating an instance of a car. We can also do this. We can target so let's say I'm only interested in the color. So purple, made it all caps. And let's say the model, a purple something, Corvette maybe, I don't know. Let's just do that. So this is one last technique for creating an instance of a struct. You can actually label the data with the field names. And if you do that, then you don't have to put them in the right order anymore. And you also don't have to supply all of them. So I'm just going to supply these two specifically and nothing else for that instance. So there's the purple Corvette. There's a little sort of gap in the output because I didn't put the make of the car. So that's 4 different ways of creating struct instances. In fact, let me put var_c2 car down here. So we can create just like a normal var, in which case we get all 0 values for the fields. We can use the new function, in which case we get all 0 values for the fields. We can preload all of the fields in order, or we can use labels to target one or more of the fields with data, and then we can choose to ignore or not to ignore other fields. That's the 4 main ways that we might create an instance of a struct. The other thing I'm going to do here before I switch over to the lab, yeah, I'm doing good on time. So you're going to see this in the lab again, but we can actually create functions. Where we pass instances of structs to them. So I'm just going to take this same code here and instead of C2, I'm going to say just C to match the parameter. So now I have a print car function. If I pass a car, it will print the information about that car. And the reason I'm doing that is because now I'm going to create more cars. I don't know why I didn't call that C2. And then let's put this one back into play and call it C3. And then we can print car C1, pass in C1, who becomes the C in question. Print car C2, print car C3. So we can actually create functions that accept instances of a struct and do operations on their fields. In this case, just print them, except for I made a mistake. Oh, yeah, let's not use that one here. Let's do it this way. I don't want to deal with that issue until we have to deal with that issue. What did, oh, darn it. Okay, anyway, so there's my print car function operating on those 3 cars. This new one, we may not even ever actually use it, but it does appear in your reading and is your homework. Oh, so Kevin K asks, is there a way to make an array out of these things? And the answer is yes. So one thing I could quickly do just to show you, I could do this. I could say cars equals, and I can make an array or a slice. So let's make a slice of cars and we'll put C1, C2, and C3 in there. And then range over these things. Car is the C. So you definitely can, and that is super, super, super useful. I can also, by the way, cars equals append cars, and then I can say car, and I can put one right in here. So I can say a Chevy Corvette. Hopefully that's right, Corvette. Let's go, oh, let's do a silver. It'd be cool. Let's do a 70s vintage. Probably also terrible gas mileage, and probably also very, very expensive now. So we can add, yeah, so we can create arrays or slices, and then we can actually append cars directly into the slice. So this car doesn't even have an existence outside of the slice, but when I print it, it ought to show up, I think. There's the silver Chevy Corvette. So very cool idea, Kevin K, and you totally can do that. And it is very, very useful to do that. Very cool thing. Okay, so 437. Let's switch over to the lab code. Let me put it where I don't forget it. I'll include a link to this stuff on the lecture page. So let me fire up. So I'm probably going to work through the whole lab fairly efficiently, but I'll talk my way through it as I'm doing it. So let me go set that up real quick. Create a go. This is lab 14. So I suspect to reward you for watching the lecture, I'm just going to solve the whole thing, and maybe that'll get you so you can put aside your worries about this class at least very quickly for this week. All right, let me go get the lab code. So this is the code. Is this the code? No, this is the test. So should put that in the test. Okay. And then the starter code. All right, so let's go see what's going on in the lab. Today's the 22nd. Okay, so I'm just going to work through. There's supposed to be 12 numbered items here, so I'm going to work through them, and then I'm going to run the unit test, and I should complete the lab. Okay, so it's telling me to create a struct, so type. It wants me to call it cart item. It will be a struct. Fields. It's going to have a name, which is going to be a string, a price, which is going to be a float 64, and a quantity that is going to be an integer. So all I did is follow the instructions just dead on for item number 1. Complete the implementation of this function. Cart item to string takes a cart item, returns a string. That's why you see funct.sprintf, because I want to not print this information, but stringify it. So can do. So let's see, I just want it to be a string. So let's see, I have the name of the item, comma, space, the quantity, which is an integer, space, at, space, $, the price to 2 decimal places, float, and I think that's it. So the data, the name will be this item, and then the field is called, if I scroll back up here, name, same item, quantity, same item, price, using the dot notation. Okay. So I will leave those up on the screen for a second. That is the struct definition, item number 1. The cart item string function definition, item number 2. I haven't tested it yet, so I may have to come and fix it. I did not put a new line on that, by the way, because it doesn't say new line, but hopefully I'm not forgetting and then I'll fail the test. But if I do, I'll fix it. Okay, item number 3. take an item and produce its quantity times its price. Okay. Item, if I multiply its quantity by its price, that would be more or less its total cost if it were in your shopping basket. So there's item number 3. It's possible I'm going to get some kind of a float 64 error on this quantity, but we'll find out. Okay, so let's see what we got. We have a all zeros instance. So item 1 is a cart item instance. This should look pretty empty to start. So this is just going to show me kind of zeros and nothing. All right, item 4, what does it want me to do? Create a cart item instance named item 2 without the field labels. Okay, so item 2 equals a cart item. And then I need to make sure I get the name, price, and quantity in the correct order. So if I scroll back up, it is name followed by price followed by quantity. So the name will be apples, the price will be 0.25, and the quantity will be 3. That's item number 4. Item number 5, print item 2 using the cart item string function. Well, I'm going to cheat because that's what this thing's doing on line 41. So I'm going to take that. That's what that's doing, and just make sure that I switch over to be item number 2. So I'm actually using a function to create that formatted output, and then I'm using the printf to display the formatted output. Print the cost of item 2 using the cost item function. I don't know why I wouldn't just kind of do this same thing. Technically, it doesn't tell me to print it, but that would be silly to not show it off. So make sure that I get item 2's name. So total cost of apples will be the computed. So I'll let the function compute and provide me with the float that I plug in here. All right, so item number 6. Item number 7. Item 3. And this time it says use the field labels. And I'm going to cheat because they're already kind of typed. So that's good stuff. So it wants me to label the fields. And remember, the point about labeling the fields is that technically it doesn't matter what order they go in anymore. As long as the labels are there, then the Go knows where to put the data. Print item 3 using the cart. Okay, well, I've done that before. So print item 3 should be item 3. Print. Oh, now it says print the cost of item 3. I should go fix that. Yeah, I should go fix that. No, let me not do it there. Let me do it somewhere else. Hold on, I gotta fix that real quick. This is lab 14. Sorry, I'm fixing the instructions because it should have said print on that one and it didn't do it. Print the cost. Oh no, wait a second. What? Now I'm confused. Didn't it say compute? Okay, never mind. It said print. I don't know what I was thinking. Sorry about that. It said print. Why did I get the idea it didn't say print? Compute. Print. Something was funny. Well, it doesn't. Oh, wait. Sorry, everybody. Just a couple minutes to fix a broken lab, I think. Okay, I don't know what happened. It says print, so it's fine. Okay. Anyway, where did I leave off? I'm on item 9. Print the cost of item 3 using... All right, so I'll just cheat and use this same one. So make sure I update it. This is one of the bad things about copy and paste programming is that it's very easy to make a mistake. So I got to be very careful when I copy and paste that this is item 3's name and item 3's cost. Okay, 10. Create a cart item instance name item 4. Can do. Using field labels. And it's telling me I've only got the name to work with. And the point here is just to remind you that you don't have to do all the fields if you don't know them or don't want them or don't have them. So I just put the name in there, and then I will print it out for item 11. And then I bet I'm supposed to compute the cost. I am. Of item 12. So I hope that you will find the time to kind of study this stuff, possibly blank it out and recreate it for yourself, but you have the option. I just did that whole solution. So let's run the program and see if it works. Unexpected quantity at end of statement on line 36. Oops. Item dot quantity, that's missing, that's for sure. Item dot quantity is the only way to get the quantity from the item is the dot notation. Okay, so I got a syntax error and told me it was on line 36, so I have fixed that, I hope. What? Oh, price 2. I looked right at it and thought it was there. So yeah, you got to attach the field to the instance, the item here. Another one on line 36. Okay, this is the one I expected. It will not let me multiply the quantity, which is an integer, times the price, which is a float. I'm supposed to produce a float, so I just need to floatify the one non-float thing. Nice one, Kevin K. You beat me to it. Yeah, so Kevin K. saw immediately that the fix was going to be to floatify the quantity. The price is all good to go. It's already a float. So we will floatify the quantity, and now we should get a happy piece of software. So that's what the output should look like from main. Now let's try the test. Cross our fingers that we pass all the tests. Uh-oh. How do I put this back? No, I don't want that there. I want it down at the bottom. Okay. So we passed the test. So small test. Most of the work is in main. So for about a minute, I'm just going to scroll back through to let it be on the screen. And then we're going to go to project demos. So you can see some of the cool things that your classmates did. All right, so there's the struct. You might not even need my help for much of this, but just in case. There is the output. That's probably the most complicated part. The cart item cost, had to be floatified. I got an error message until I made the quantity temporarily be a float for that calculation. That's the first 3 items. And then main. So there's 4, 5, 6, 7, and 8. And then there is 8, 9, 10, 11, and 12. And that completes it. And I've run it and it works and passed all the tests. So that's the lab. You don't have to use it if you don't want to, or you can have a crack at the lab and see how far you get. And then you can refer to this stuff. Up to you. But anyway, there's the lab work through for the week. And I'm just going to go straight into doing demos. So let me make a REPL for that. And then start copying them in and running them. P3 demo. Okay, so here come the demos. Let's make sure that might be the sort of the crazy epic one. All right, let's start with this one. Now, I want to get big screen for this run. All right, so I ended up with like 8 or 9 demos, so I'll just kind of give you a flavor of each of them just so you can kind of see what people did. Yeah, this one's pretty cool. It's got ASCII art in it, which is really nice. So I'll just play it for a minute or two. Yeah, so really cool display on this one. Just looks really nice on the screen. So props to this person for taking the time to make very pretty looking output on the screen. I haven't tried swimming before, I don't think. Well, let's look at our inventory first. I got nothing right now. Let's swim. I don't know that. I could cheat. I'm tall when I'm young and I'm short when I'm old. What am I? I don't know. I'm going to get it wrong. I could cheat, but it's not a horse. Anyway, little riddle. So you get a flavor of that one. It's cool. That was that one. All right, so here's another. Yeah, so this one's got a lot of narrative in it, which is kind of cool. Oh yeah, this is cool. I already know this one because I've played it. So checkmate is the answer. Oh, I think I didn't. Oh yeah, because this one's random. This puzzle is random, so you just kind of have to get lucky, I think, if I remember correctly. Holy moly, I've never got it open. Okay, let's try left 4 since it suggests that. Anyway, there's the flavor of that one, which is quite cool. I'm just checking to see if there's anybody in chat. Okay, so that's another one. Let's get another. Wait, is this the same? You know what? Is that the same as 9? It is, but 9's the newer version of it. Oh, sorry. All right, so let's try this one out. Yeah, this one's got cool ASCII graphics in it as well. So it'll be a dwarf this time. I've always been an elf. Oh yeah, this one has the cool health meter. Oh wait, I'm supposed to do something. Let's go to the red room. All right, anyway, this one's got the cool health meter on it, which is cool. This is not going well. I might die. Okay, I won. Third number in the code is a 3. Oh, that's very cool. See, so pretty cool. So I don't have time. I don't want to take your time up like playing all the way through them, but this one's really cool looking, and it's got some really cool features in it as well. I like the code number puzzle, and I like that progress thing. That's also very cool. So this is another one that did ASCII graphics, also with some sort of emoji style graphics in it. It's cool. This one's got a, yeah, John Muir Trail. That's this one. So I've got the sort of, I think have I been down the Mist Trail first before? Yeah, this one's quite cool. It's got good gameplay in it. Am I going to lose here in a moment? Anyway, you get the idea. I'm going quickly through the narrative, but this person also took the time to craft some narrative and came up with a good theme and a good kind of gameplay mechanic with the mileage gained and that kind of stuff. So quite cool. Thanks for doing that. So that was a cool one. I might have made a mistake because this one does build. What? Line 303. Yeah, I did. I made a mistake somewhere. Yeah, okay, here we go. Graphics. Oh, this one's got a cute theme also. And the locations are actually pretty elaborate. So the barn isn't just the barn. There's other places to go. I do. I've never tried a lot, by the way. Yeah, so they attack you for your trouble, which is pretty funny. Okay, I'm getting out of there. Oh, I can't take off. I have 0 flying skill. Anyway, that's very cool. Very cool game. This one had something in it that I liked. Oh, yeah, I liked that this person used the little emoji graphics for stuff. So let me buy some treats. And then I think if I go look that my little treats are graphic. So I just thought it was a really cute little touch. I like it. I'm going to steal it when I do. Next time I do a Go language little text game, I'm going to take that idea because I knew you could do that. It never occurred to me that I could make those little text things look better. I think it might even be useful in just a regular old program. So nice touch with the little item icons. I didn't close that. I think it's, yeah. Number 2 is the sort of very epic one. So I'm saving it for last. Oh yeah, this one has a good theme too. You're on the Butte College campus. Trying to do stuff. I'm going to do the sequence because I'm pretty sure I remember it. I got to go to Cass, I think. Yes. So I got to go to... Oh, no, I got to go to the math building. Yeah, that makes sense. Thematically, that makes sense. I already remembered that number because every one of your games that were playable, I played them through enough times to remember kind of the big moments like this one. So I got the code. I think if I go to the... Oh, darn it. Yeah, I have the code. Wait, is this the code? Yes. And then now I can go to Cass, and I think something happens in Cass. Oh, yeah. Anyway, there you go. I don't know what happens at the end of this one. It runs all the way through to completion, and then something weird happens. Anyway, cool game with a cool Butte College campus theme. And then this one. So I just want to show you. This wasn't the only one, but this person's program is almost 1,500 lines of code. Now, over the course of a month, that is still what? It's almost 400 lines of code a week, which is more lines of code than some people's whole programs were. That wasn't really a measure of the credit that you got on a game, but just to kind of, it's a good reminder that the people who are getting good at this stuff are getting good because they are doing a lot of work at it, which is just what it takes. But anyway, check this out. This one is crazy. So it's Oregon Trail. Got lots of ASCII graphics in there. Who else? So take my dog. I will take, I don't know, who else should I take? Take my brother-in-law. Take my niece. All right, so we're all on the trip. I need to give this more screen space for it to really get to shine. All right, it's about it. Okay, anyway, we'll just deal with that. I don't want to full screen it because I think it'll screw up my streaming. Look, anyway, crazy. I can afford them, so I don't know what's the smart choice here. I actually was in school before Oregon Trail was a thing. 50 bullets. I don't know. Let's buy 20 food and let's just have some money left over. Take my time. Oh no! I know this is nuts. Yeah, I'm glad there's some people here live because I want people to just. This one's really good. This person put a lot of work into it, and not just this program. Of course, this person has put a lot of work into their programming skills to get them to this point, and then they can show what they can do with it, and it's really neat. Let's see. Something you like stop and do. Let's. Oh yeah, because the bandits took me money. That's a bummer. So I can go hunting. I missed. Crazy. Okay, that's enough hunting. Maybe I'll find gold. 10 feet? Okay. I'm not going to get any gold. I didn't get any gold. That's a bummer. Alright, so let's just bust on through. Anyway, you get the idea. That's a crazy amount of work. And like the graphics, there's actual gameplay in there. So very nice. Very cool stuff. The person that did that is super, super cool. So that gets us just over an hour, which my goal was to stay at or slightly less than an hour. But anyway, I'm going to stop there before someone dies of dysentery. I don't know if that happens, actually. I haven't managed to trigger that yet. But anyway, good work on the projects. I know some people, a lot of people kind of waited until the last second and then rushed through and didn't get the result that you wanted. So it's a good lesson to learn. At least kind of walk away knowing that that is not always the best approach for building software. You want to give yourself time, especially when you're doing something, and I'm just saying this in advance of Project 4. Project 4 is not a game. It's really a place to gather up all of the programming techniques that we have explored up to this point in the semester and then the next couple of weeks. But it can be very, very helpful if you have a non-programmer person that you know at work or at home or a friend or whatever. If you can sit them down and let them kind of use your software and interact with it, and they can often non-programmers are very good at finding bugs in software. They just naturally find their way to exposing bugs. So you can use them to help you get a better result with your software, but also just as a heads up that giving yourself plenty of time to work on it over time is in my opinion the best approach. It's really the only approach to build real software. Is to work on it steadily over time, making additions and improvements and testing and improving until you get to that point where you hit a deadline and then you have to release your software. Okay, that's it. Have a great rest of your week. If you're doing a Thanksgiving thing, enjoy that, or whatever it is that you're doing. For the rest of the week, hopefully you have time to rest and recuperate, and then we have a 3-week sprint. 15, 16, 17. Yeah, 3 weeks, and then the semester's over. So someone's asking about plagiarism. So Yeah. So, um, well, plagiarism in programming is the same as in anything else. Um, you put your name on something that is not your own work, um, is plagiarism. Code or an English paper or whatever. Um, we don't always find it, but usually people who are plagiarists are not smart enough to mask it very well. So they usually leave some obvious kind of telltales as they are in the process of cheating. So I see that and I can take, for example, two pieces of code that look the same to me, and I have a piece of software that compares them and tells me what the differences are, and that makes it pretty obvious when cheating has happened. Um, so in school, of course, that's a terrible thing, and some teachers, they have the right to pursue kicking you out of school for that, and certainly they have the right to pursue giving you an F for doing that. That's not the way I deal with the situation. Um, but that said, why it's a big deal for us programmers is because if you steal someone's code in the real world, you are going to get sued, and you're going to get sued for a lot of money. It's going to be the end of your financial well being, and it's going to be the end of you being able to have a career because it's copyright violation, among other things. Um, so the question is there a would there be a way to find out who cheated or stole the code? Um, I don't have a comfortable way of doing that without possibly violating people's privacy. Um, so I am willing to show people. I mean, I take the names off, but I'm willing to show people uh, the code, the view that I have of the two pieces of code that are the same, and then that may or may not sort of help you identify who the culprit is. Um, Traditionally, usually the cheating culprit is someone who, hey, I need your help on the project, or can we get together and study for a while, and then they end up turning in something that looks very much the same. Um, yeah, so I wish I had better answers for any of that. Um, I don't think I can, without getting a lot of us in trouble, share the names of people who were doing the plagiarism, but just know that it will be dealt with um, harshly up to the limits I'm comfortable with, and also hopefully fairly for the parties. Um, yeah, so how do we protect ourselves against code being stolen? In a public REPL, you can't. So if you are using REPLit, the only way to secure it against people um, stealing it is really to put it in a private REPL. You could put a license statement on the top that says, and basically that's what I have you do already. So that your name is at the top of your code is a copyright claim. Um, and since there is no information that says you're happy to share this with the world, in theory, that's a copyright claim that I think is enforceable. I'm not positive about that. Um, so a private REPL, but sort of moving forward, I would say the best way to protect yourself is to work offline, to not work in a REPL. Um, Unless you can afford the cost to pay REPLit to get private REPLs, which is what I do, for at least for some of my school work. But my real work I do offline, and I secure it um, by storing it on my computer and by storing it in um, GitHub repositories that I can lock down. So if you make a REPL private, you can add me, you can invite me as a contributor so that I can read it. So I'll show you actually here on this screen. There's an invite button up here, and you can ask people, you can invite people to join your REPL so that they can view it. In theory, they can also edit it, but if you're doing a share with me, I'm not going to edit it. So that's what I would do if you want to sort of your two options if you're worried about being plagiarized, being the victim of plagiarist. You could pay for 1 month of Repl so that you can have private repls and then invite me as a contributor so I can see it. Or you can work offline, and if you choose to work offline, then we can communicate with each other to make it so that I can get your code from you just directly between us, probably through Canvas Inbox or something like that. So yeah, if you're concerned about it, I'm willing to work with you, and I can help you get set up to work offline in Go if you like as well. It's relatively easy to download and use the Go programming tools on your own machine. You just need the Go tools and you need a text editor, and you can work offline. Okay, anyway, sorry that the answers aren't the greatest. And it's disappointing when people sort of violate our trust that way. It sort of has a ripple effect for people. But it is one of the reasons why I have you put your name on everything, because that is a form of a copyright claim. So when someone did that, they didn't just plagiarize, they actually made a copyright violation by stealing your intellectual property. Okay, anyway, I'm going to close down so that you guys can go do other things. And I'm more than happy to communicate with you directly if you have questions or concerns about securing your intellectual property, your code. The labs are usually pretty trivial, but if you're starting to develop bigger things, then yeah, you probably want to take extra measures to keep it private, unless you're purposely doing something so that it will be public. Okay, so anyway, demos are fun. Thanks for being here for the live stream if you could. Thanks for watching later if you are doing that. Have a good rest of the week. I will see you on Tuesday next week for the sprint to the end of the semester. Yeah, that's a closing thought. So with the struct, it would be nice to redo project 3. So for me, I would probably just, if it were mine, I would probably just go back and do it as practice and sort of, hobby for the enjoyment of it. If you do go back and do something to make your game different or better, I'm more than happy to go look at it and play it. And if you want feedback, I'm happy to offer that as well. So yeah, take care. I'm going to cut out.